Give me this, I should better use it. Thanks everybody for coming tonight. My name is Eric Christoph. I'm filling in for our founder and president, Dave Hurst, who is out this week at the Space Resources Summit, I believe it's called, out at the Colorado School of Mines. So he's learning about asteroid mining and things like that. We'll hear more from him and how that and the things he's learning when he comes back next time. Just a couple of points of order. Okay, sorry about that. First, I just want to thank our sponsors, M.Phil, for letting us use the facilities here for events like this. We do these every month, except for a couple months in the summer. And then Metropolitan Brewing, who is bringing you the delightful barley flavors of Chicago. So we appreciate their sponsorship. This actually is an event tonight that I've been really personally looking forward to a lot. I think we're all in for a really big treat. Michael Dunn here has an incredibly fascinating personal and professional story of adventure and exploration. There was just one interesting nugget to characterize it is I believe you're not only the first but the only one to get Sir Edmund Hillary and Neil Armstrong together on the same adventure. Which is just incredible back in 1985. And so, given his deep experience in expeditions and work all over the world, including in Antarctica and in the Arctic, and he has he and his wife have formed a company to chart a vision and develop the technologies for human settlement deep into space. And so they're going to share with us that vision and for how that's going to develop and how people are participating in that. So one last little point of order before we kick in for the next thing is for next, we always take a couple months off in the summer, so this is our last event of the spring season. We're going to be starting up again in September. And the person who's coming back then is Stofield Aerospace. They're going to be reprising their earlier plastic 3D printed rocket technology. And then something that we've started recently, we're not doing it tonight, but at the next event in September, is these mini pitches or lightning pitches, where this is if you've got an idea, it could be a business idea, it could be research, it could just be something that earliest kernel of an idea that's space related. Get up here and spend 2-3 minutes, pitch it to the group, help you practice, communicating the idea and get some feedback on it. So if you have something you want to try, it's a friendly group. All ideas are welcome. So give some thought to that and reach out to any of us. We're in the name badge, and we'll get you set up for that in the fall. So with no further ado, I'd like to introduce Michael Dunn.
Good evening, everyone. I really want to thank New Space Chicago for allowing me to have this opportunity to speak with you this evening, to kind of describe what we're doing, how we're going about it. And basically, the name of our company, Fourth Planet Logistics, we basically look at developing habitats for Lunar-Mars application. The bottom line, arrange your flight off-planet with anyone going your way, but be sure to book your room early with Fourth Planet if you're planning on staying. Last Friday, I was doing a presentation in DC for the International Space and Development Conference, and was asked by one of the folks during dinner, we were sitting there chatting, and he said, if you had some money to spend just on some type of advertising for your company, what would you do? And I basically took this little saying here and I said I would put a billboard in front of Spacex, Blue Origin, Lockheed Martin, and United Launch Alliance where people came in and out with this little logo on it. So who are we and what do we do? Tonight I'm going to start with giving you a brief idea of who we are, what we do, and why we do it. The thing I kind of want to emphasize as you're reading this is that Fourth Planet is a field engineering and technology development company. That's the important part to keep in mind here. Because what we are, in essence, is a second generation, a second phase towards the concepts and ideas that are going to move us from this planet onto others. Now, I'm sure all of us that are here, the reason we're here is we follow the exploration of space, of Mars, and of the Moon. And if you look at most of the stuff that comes out in the literature these days, it's reasonably speculative. There's great pictures of moon bases and how we're going to work on Mars and what we're going to do. But most of it is conceptual. Well, we've reached that point in the evolution of our quest for reestablishing a permanent base, at least for now, on the Moon, to the point where we need to start transitioning those conceptual ideas into actual application ideas. So that's who we are, and that's what I'd like you to keep in mind as we move through the presentation tonight, is that Fourth Planet Logistics is actually a field development, research and development type company. We take concepts and turn them into engineering that we can test in the field, even if they're just kind of remote prototype ideas, as long as their progression allows us to move forward and learn from it. That's in essence what we do. So who are we? Basically, Fourth Planet Logistics started as a conceptual program in Iceland back in 2016. During a travel trip, I guess you would simply call it, into Iceland the year before, I went by a museum in Husvik, Iceland, the Explorers Museum, and I presented them with some documents, some letters from Sir Edmund Hillary and from Neil Armstrong, because that particular museum basically dealt with NASA and the Apollo programs and what they did in relationship to training in northern Iceland during the Apollo missions. And just by coincidence, my wife and I happened to be driving through Iceland. I also was looking at some things on the internet and saw a picture of myself standing at the North Pole with Sir Edmund Hillary and Neil Armstrong. And we had been just recently through a bunch of stuff in the basement. And I said, you know, I'm going to give some of this stuff away to a museum somewhere. And rather than send it to one of the main museums, we drove into Husvik. I handed it to the guys at the Exploration Museum, and we walked in, paid to go in the museum, and looked around, and they opened it up and kind of went holy doo-doo, and basically got a hold of the guy who was the head of the museum, and now it's part of the display there. Well, from there, the next year we were invited back. I was invited back to give what was the first presentation I did on that 1985 expedition, because we had a gentleman's agreement that I would not basically promote or tell stories about the expedition until both Neil Armstrong and Sir Edmund Hillary had passed away. And that was the first opportunity to do that. I got into my slides, I put together a program, and I went back to the Explorers Festival. Well, they also wanted some other kind of notable people to show up. The gentleman on this side is Scott Pirozinski. Scott is most well known as an astronaut, retired astronaut, a medical doctor. He was trained at Stanford, but he was also the first astronaut to summit Mount Everest. So I got on I was going to say the phone, but actually I just messaged Scott and said, hey Scott, you interested in coming and telling a story about one of your recent adventures at the Explorers Festival? And he said, well, yeah, sure. So he put together a presentation on a descent they did in Nicaragua into an actual live volcano to a lava lake. So Scott and I were both there, basically to do presentations. The gentleman in the middle is a man by the name of Goodney. Now, I'll back up a little bit. In Iceland, almost nobody uses their last name because their last name simply is their father's name. So Goodney is the president of Iceland, and he attended the presentation that we did. and then off we went and did a mountain bike trip across the island thereafter. Iceland's a little different. You actually can walk up and knock on the door of the president and go, hey, good, you want to go do a bicycle trip? So a little different than what we have here. So during the Exploration Festival, this gentleman, who's a geologist and a premier caver, he holds both citizenship in Switzerland and in Iceland. His name is Martin Gasser. And Martin basically did a presentation. And his presentation was on some of the very first remedial pictures of lava tubes on Mars. And one of them was actually an extrapolation of a horizontal entrance, which seemed to be indicated in one of the pictures. So he did a presentation that Scott was in, myself, my wife, Dr. Ann Hartree, Scott's wife, who is Mina. She happens to be the planetary geologist that runs the department at the University of Arizona State University. So we were there along with some other people, and he made a presentation on this particular location that was in some of the first telemetry that came back from Mars. Of course, for some time, we had been discussing the idea of going subterranean for future habitation, both on the Moon and on Mars, but very little evidence. So Martin triggered this whole idea that we would potentially move forward. We had some meetings. Most of it involved more than one pitcher of beer. And basically, we moved forward. The next person, in the next slide, is Krista Maria. She's also a master's degree geologist who happens to be Martin's wife. And she was running basic programs in Iceland at the same time. Again, speaks fluent Icelandic. Again, holds citizenships in both Iceland and in Switzerland. In fact, they are probably the most enthusiastic people that you can find relative to the types of projects we're working on. The only thing I have to say to describe that, so you get the picture, is Krista and Martin were buried in a lava tube. Okay? So they joined the effort. And one of the projects that we were working on in Iceland with the Exploration Museum is Oliver, who is the person who's the director of the museum, had a program where he was inviting the past moonwalkers into Iceland to go back to the original geological training areas that they had. Jack Schmidt, Charlie Duke, a number of the others all basically came to Iceland. We have a funny saying that the high school kids in the small community in Husavik, Iceland, which constitutes, I don't know what, maybe 112 kids, have met more people who've been into space and walked on the moon than most anybody else on the planet, because eventually over time almost everyone showed up there. So along with Oligar and Martin and myself, we went back out to the areas where the astronauts basically train, and we started talking about finding a lava tube that we could use in Iceland for the purpose that we were looking at, which is basically to figure out if there was a way we could develop field training programs for the purpose of realistically looking at lava tubes as a true potential, as an alternative for establishing habitat locations on Mars and also on the Moon. So after we moved back out of this whole scenario over a couple of years in Iceland, we started picking up an advisory board. The advisory board was pretty impressive, because what it involved was a whole lot of people in a whole lot of different disciplines who really felt that this might truly be a way to go in looking at the most cost-effective, efficient way to generate a extended long-term habitat on another planet. Francis Grovers, the gentleman over here, is a robotics expert. He's written books on artificial intelligence and robotics. He worked for DARPA. He worked for the Advanced Research Development Programs for the United States Army. Over here, he also now works for Boeing. So what we have is people on our advisory board that are not only working with us, but they're working with the principal people who are involved in a lot of what's going on in the new space industry. The man on the top, Phil O'Hara, he works for Sierra Nevada, and he is basically involved in systems engineering and development programs that include their inflatable habitats and their organic gardening and space programs. He also is on our advisory board. On the bottom is Anne, who's secretly sitting in the back. Dr. Anne Hartree, she's a cognitive neuroscientist that works with us. And she's a wonderful person. I have to say that, even though I really do, because she's also my wife. Okay? So this is our team. There's others. There's Dr. Jim Rice, who was heavily involved when he was at JPL with the first 2 rovers that went to Mars that have recently been decommissioned. Other folks like that. So what do? We just said who we are. Now, what is it we're actually doing? What are we doing out there in the field? Well, we've established cooperative agreements with academic, governmental, and private organizations to support the development and testing of Lunar-Mars subterranean habitats and greenhouse designs. You can read this as well as I can, but I'll start with that and we'll work our way down the list. We also are basically involved in a number of commercial astronaut subterranean orientation and field exercises, both in Iceland and also in the United States. Different groups, but basically they're the kind of folks that we deal with are commercial astronaut training programs for a company called Advancing X and ESA in Iceland. We also are field testing robotics, LiDAR, which is basically ways to survey the cave systems robotically so we know the configuration of the cave systems and where would be best to put an inflatable habitat, where would be best to look for what we call damming or channeling environments where it's easy to basically put pressurization walls within a lava tube so that we could eventually partially or modestly pressurize those lava tubes as secondary backup contingency environments in the case of a failure within an inflatable habitat. We're also now getting into a thing called periscope, which I will talk to you more about. Periscope is a game changer for our industry. Periscope allows you to basically do a look down at an area, a topography, look below the ground, and find lava tubes. It's part of a program that was done by DARPA to allow soldiers to look through things like concrete walls to see if a bad guy was back there. JPL and a company that I'll talk about a little bit later are now using it, and if we can get that into space, we'll be able to identify all the locations and all of the channeling on the moon and where the lava tubes are, and that's a biggie for us. We're also working on inflatable subterranean habitat and greenhouses, doing research on basically growing things underground and how to best configure the habitats. These are all the things we'll go through in some of the other slides. We're also doing in conjunction with academic and industry partners, and I especially want to talk about industry partners because that's a double-edged sword in many ways, which I'll explain a little bit later, in the US and Europe. Developing flexible composite airlocks, because we have to be able to compress it down to the point where the airlocks can basically get to the moon, and then basically allows us to unpack them, put them into a inflatable environment so that you can move in and out. We're not going to be able to take really strong, rigid, large airlocks and get them off to the moon. It's going to not be very practical. And that's the area that we're having our greatest challenge with now, is how to best do that. We're working on the project with the University of Bristol and their advanced textiles department. Also looking at field testing of 3D printable approaches to building subterranean barrier walls. This is a new one. It's not new in that there are a number of folks out there, and I think even Kat came in here and did a presentation at one time relative to 3D printing. There's been NASA contests for 3D printing habitat facilities, but no one has actually looked at what is necessary to configure and engineer the robots so that they can get down into lava tubes to build barrier walls in a subterranean environment. That's where we're moving now. Part of the reason we're moving that way is so much of the industry and so much of the new space community is starting to step back and look at the possibility of going subterranean as a truly potential alternative approach. The last one on here, which I want to talk about a little bit because it's a philosophy thing, and that's Olympus Mons 3D virtual reality climbing expedition. Well, what does this have to do with field training? It's something of an approach that we're using in order to get millennials and the outdoor gear and sports industry more involved in looking at the potential for being involved in Mars and in the space industry as a whole. So if we get a virtual reality thing that the kids can do at home that basically says North Face on the tents and Nike on the boots, and off they go to climb the highest mountain in the solar system. This isn't the 7 summits here on Earth, those are piddly. Olympus Mons is 16 miles high. So that's basically the programs that we're looking at right now. So why do we do it? Well, we're doing it because it's the next step in exploration. It's what we want to do. It's the passion of the people that are involved. A lot of the folks that we're involved with are retired out of NASA, retired out of JPL, retired out of the European Space Agency, or they're kids that are coming up in STEM programs or doing their last year as an undergraduate or doing graduate programs in areas and expertise that want to step back and say, the next future in exploration isn't always going to be on this planet. It's going to be moving towards other planets. So we bring those people in as interns. We develop programs where they look at various projects, and then they go out and apply those projects to potential funding sources. And if those funding sources are picked up, we then incorporate them into the programs. This is a model that we started back when I had a small company in Antarctica. It was the first company in Antarctica that was privately owned. It was called A&I International Antarctic Airways. And what we would do is we would hire kids to wash dishes and basically, clean stuff and refuel airplanes in the Antarctic. We didn't pay them anything, but we gave them good sleeping bags so they wouldn't get cold. And if they performed well, the next year they came back as paying members of our expedition teams. I want to also talk a little bit about what we don't do, because that's important. My background is exploration and expedition management, evaluating high-risk environments and working with them, but also general systems theory applications, which basically means taking all of the subcomponents and translating them into an overall project. What we are not doing is we are not basically doing programs such as putting a analog habitat inside of one of our lava tubes that is created by some guys in a truck that come up with some hammers and nails and plywood and build basically a modular living environment for somebody to stay in the habitat in the lava tube. That's human factors engineering. That's human systems engineering. That's looking at the interplay between people in a closed, hazardous, or remote environment. That is being done a lot. It's being done in Hawaii. It's being done in the southern part of Utah. It's being done in a lot of locations around the world. The distinction is no one now is doing what we call phase 2, which is saying, okay, we're more than happy to have you come and build a habitat inside of one of our lava tubes, but it has to actually be a prototype of something that could eventually apply to being put onto a spaceship and launched and brought to the moon. So if you have a design or an idea and the resources to create an inflatable greenhouse or a robot that can perform in an inflatable greenhouse and it's not quite ready for the moon, we can basically take it and field test it for you. We can send it to vacuum chambers that we have. We can throw moon dust in there. We can drop the temperatures to what you want. But it has to be something that's at least a conceptual prototype, baby first step to something that can progress to an eventual use on the moon and eventually Mars. Now, for planet expeditions, one of the interesting things that people ask me is, well, you talk a lot about the moon, but you guys are really talking about Mars. Well, the moon is the logical stepping stone to Mars. Very much like when we first started working with our first undersea habitats. One was Classroom in the Sea at the University of Florida. We used to call it the soup can in the sea, because it's a tiny little thing that you were in. That thing was so shallow that you could probably stand on top of it on your tiptoes and watch the boats sail by. It wasn't at 3,000 meters below the ocean. The first bases in Antarctica were on the perimeter. They didn't go to Antarctica and immediately go to the South Pole and establish a base. The Edmund Scott base was established in 1958. Okay? So those are basically the models that we want to use because they're proven track record models for going to Mars. The moon is 3 days away from Earth. That's not that far to get to the hardware store if you need to. Mars could be 9 months to a year and a half away. That's a long ways to need to go to the hardware store to get something that's going to keep you alive. So we will learn on the moon what it is we need to do to progress to go to Mars. One of our main projects is Stephenhof, which is a cave system, a cave complex on private land in western Iceland. This complex is almost perfect for what we're trying to do. It has 3 vertical openings, which we call Skylights. It has 3 horizontal openings, which we call easier to get in. And basically, it allows us to do a whole bunch of different things. Each of these numbers is a different location that you can see where you can enter or exit the cave system. There's also a maze in there. It's a great place to take robots in and see if they can stay running around, if they can basically do LiDAR scanning and stuff. And there's 2 things that are really optimum about this cave. One is the cave was pretty much destroyed by tourists back in the 1900s. So all the stalactites and stalagmites and all the rest of the stuff is gone. So it's a pretty sterile cave. That means that we aren't basically destroying the cave when we try to figure out ways to seal the walls in order to create pressurized environments. In fact, what we're doing is mostly bringing the cave back to its old level of awareness within the local community in Iceland. One of the things we're doing is our Iceland projects are a non-profit organization. This was a learning curve based upon a lot of the stuff I did. Anybody here familiar with everything that's going on Mount Everest right now? Okay, so Mount Everest is kind of a free-for-all. Anybody know much about what's going on in Antarctica right now? Antarctica seems to be a pretty well-controlled environment. The tourists, the scientists, the rest of the folks down there seem to do pretty well. Everybody gets together, and for example, in 1991, in Strasbourg, France, we had a meeting that incorporated in the Antarctic Treaty a set of protocols for tourists and visitors. And when I say visitors, I mean scientists that aren't on national programs, that we would fly into the Antarctic, somebody who needs to get to the Antarctic to finish up their field work for their PhD or what have you. And that seems to work pretty well. It was modeled to a certain degree on the Grand Canyon, the National Park Service, and how they treat the bottom of the Grand Canyon, which is basically the Colorado River. Anything you take in goes back out. So the sweet boat, the boat I used to run when I was a kid, basically started with lots of peaches and ice cream and hot dogs, and ended up with big rocket cans full of doo-doo by the time you got out of the river. So this particular site, we have coordinated with academic communities and the government of Iceland for the purpose of trying to control what's going to happen, at least in their country and a couple of other locations around the world, relative to less than ethical people coming in and saying, hi, come with us, let's go down in this cave and we'll let you do paintings with spray cans on the walls that represent what's going to happen on Mars. So we're trying to move forward in a way that we understand is going to be more like Antarctica and the Grand Canyon than what's happening currently on the south side of Mount Everest. The last thing I want to see is the development of a company that has places on the moon where a tourist goes out in a spacesuit and says, here, look, watch me put my foot in Neil Armstrong's footprint so you can get a picture of me. And that's what we're attempting to avoid, or at least mitigate to a certain degree. Next slide. Okay, so just to show you kind of an idea of where we're at. Here's Greenland, that's Iceland right down there, Spitsbergen, Ovidius, Norway, and over here is basically Baffin Island and Ellesmere Island. And next slide, please. Okay, so now we're going to go into the cave system and show you what we're doing. These are LiDAR point positions that establishes basically the configuration of the cave system. And keep in mind, this is somewhat what we'll be doing literally on the moon. You've got to send a robot in to find a location where you can establish the size configuration so you can come back and build an inflatable habitat and an inflatable greenhouse. These were fixed point. We're also working on robots to do the same thing. But it gives you an idea of what the cave system's like. Next slide, please. So now let's talk about a game changer for us. And that is basically this image up here is a LiDAR scan actually physically done inside of a cave. This picture down here was done by helicopter flying over a series of lava tubes near Lava Beds National Monument in California. So this is ground penetrating. This is what I talked about. This is the same technology that allows the military to see through a brick wall to see where the bad guy is at. So that's pretty significant. That allows us to do a whole lot of basically remote imaging and analysis to know where the next step would be, which is to then take the robot, land it on the moon, and head it over to what you think is the optimum lava cave to potentially put a habitat system in. Next slide. One of the other advantages of it, this is an orbiting resource satellite image looking down into basically a skylight of a lava tube. This is the periscope system. The periscope system is the one that we were just showing you. Why is this important? Because one of the things we're going to be looking at on the moon is for water. And one of the places water is going to probably be inside of the lava tubes is not on the top of the skylight debris where basically the top of the lava tube fell in, because what is it going to fall on if it's there? It's going to fall on top of the ice. So where is the ice going to be? The ice is going to be, if it's in this location at all, in the proximities on either side. And this allows us to look at that. And in fact, just recently, within the last few weeks, they have established that there's at least one lava tube that's in a close approximation to one of the poles on the moon that they believe is showing imaging of ice. That's a huge deal, because ice is water, and water can break down into hydrogen and oxygen and become a fuel supply. It also basically allows you to sustain life and to be used basically for the propagation of plants for your growing. Nice thing about a lava tube, let's say you start out with a small community on the moon, and that community is 20 people. And you've sealed off a small section of the lava tube. And inside there, you have robots tending, and you're growing your food and produce. You're growing your potatoes if you're really into the Martian. Or you're growing whatever. If you're from Iceland, they want to grow bananas. But I don't even want to go into that right at the moment. But in any event, you're growing something. Now, 5 years down the road, hey, we don't have 20 people anymore. We got 120 people. We've got to feed 120 people. If you're on the surface, that means building more buildings that are basically going to be greenhouses. Inside a lava tube, properly positioned and properly researched, you take one wall in the back of the greenhouse and you move it farther back into the tunnel, and you create a larger greenhouse that can support the larger population. So basically, you're not lifting hundreds of tons of equipment off of Earth in order to build another greenhouse. Mother Nature has basically already done it for you. This is a picture that's almost 4 years old now. And it was by one of our materials engineers who did a write-up in one of the technical books. And basically it's a robot that's spraying the interior side of a lava tube with an epoxy resin that can also be applied for an ultra-high molecular polyethylene environment along it, and for the entire purpose of being able to at least moderately pressurize the lava tube. Today, there are actually spider-type robots that are literally commercially available that we can play with down in lava tubes that can run down in there and look at basically doing the same kind of thing that this would do. But guess what? We don't need to. All of these epoxies and all of these resins that we originally thought were going to have to get off of the planet Earth, and at $15,000 to $250,000 a kilo just to get it into low Earth orbit, let alone to the moon, is now starting to become somewhat irrelevant. And why is that? Because we've discovered that there is water on the moon. And water sprayed on the interior of the lava tube has the potential, we haven't researched it yet, we're just now looking at it, but it has the potential to basically create a pressure barrier within the lava tube that can then be used as the primary pressurization system, where then the inflatable habitat comes inside and it gets pressurized. Without pressurizing the lava tube, if you have a failure in an inflatable habitat, your planetary explorers are basically done. If you have a failure in a inflatable habitat inside a modestly pressurized lava tube, they can just simply go, oh, well, that's a bummer, and patch the inflatable habitat. It's very much like skydivers. Anybody ever wonder why skydivers use 2 parachutes? One of them opens like 999 times out of 1,000. But the one time it doesn't, your contingency plan, your reserve parachute, and your trigger for your contingency plan, which is opening it before you hit the ground, become very important. And that's part of the project management approach that blends the science, which gives you the parameters of what you're going to be able to do. They're telling you, here's the science of what you can work on. And the engineers are saying, we have to build within the parameters the scientists give us. And the project managers basically saying, we have to get the resources and attract the people, and they have certain things that they want to do too. If they want a nice hotel where they can have lobster thermidor in their underwater habitat, which was one of the recommendations we made when Jules Undersea Habitat first came out, is, treat the people a little nicer than beans and weenies inside of your underwater habitat. If the people that are paying for your subterranean habitat are predominantly tourists who are subsidizing the science, then one of the things you need to do is address their needs. And their needs might not be the most effective and efficient approach to how you do toilets or how you do showers. But if you get no funding because you don't attract the people that have the resources, then it doesn't matter how good the science is and how well they have managed to basically establish those parameters. And it doesn't matter how good the engineering is, because none of it is relative to anything if you can't fund it. And honestly, from my point of view, having watched what happened with what we thought was an initial project to climb the 7 summits, which would have involved no more than, in my lifetime, 7 or 8 people turn into what it was, and underwater habitats turning into the locations they are, and people like Musk saying we're going to send people to space, and people like Bigelow saying for $52 million we'll put you in the hotel on the old space station. It's pretty logical that this is a progression that's probably going to happen. Next slide, please. All right, so I also talked about our training program for future astronauts. This is the geospace team in Iceland. These young ladies range from the one on the right being a PhD astrophysicist from Cambridge University, my old heart, yeah, all the way over to the middle being a high school student who's in an accelerated STEM program, to the one on the far left who is Amelia Rose Earhart, who is from Colorado, who flew a plane solo around the world. So this was our first team. They went down into the lava caves in Iceland, and we did some training and some exploring. and it was a pretty fun time. It actually, to a certain degree, impacted our science because we were trying to do some tests on permeable wall systems on the cave, Martin, Gasser, myself. And we were so inundated with people just up there because of the interest and because of the ladies and the news media and people that it was a rush by the end of the season to get most of our work done. Martin's going back with a team now from ESA, a team of student astronauts, to retrieve the data instrumentation that we left in the lava cave system to determine how the humidity varied during the winter, the temperature variations during the winter, airflows during the winter, and things of that nature. We put sensors inside the caves, and then we put a repeat sensor on the surface, directly above, where below the surface the sensors inside the lava tube complex were. We're also doing a project, before I get to this one, in the western U.S. with a company called Advancing X, where we're basically doing orientation training for people who are looking to get into commercial astronaut programs. I mentioned inflatable habitats and inflatable greenhouses. This is an initial prototype, and I will point out, ladies and gentlemen, that is not an airlock. Okay? So we are looking at using these types of configurations. This one is actually Hyperlon. We will go to basically a spread fiber ultra-molecular weight polyethylene component, Dyneema. Or if you're in America and you work for Honeywell, Spectra, basically the same molecule. And using that, because of how strong it is, and how light it is, and how easily and compact it is, to get these things up to the moon. This particular one will be in Iceland, and it will be used to grow bananas, I think. But in essence, this will be have LED lighting, and we'll be looking at one of our challenges in Iceland is that there's so much geothermal energy. The folks in Iceland don't pay much attention to energy sources. Boy, are they good at growing stuff in the winter in the dark, and boy, are they good with LED lighting. But boy, are they not so good with looking at alternative energy sources for applying to what we're going to need to do, because their general response is, just grab the geothermal stuff that's on the moon. Probably not going to work that way. Now, the last one I talked about on that third slide of all the things we were doing. Olympus Mons, 16 miles high. The circumference of the mountain is the size of the state of Arizona. Think about it. The red planet's a lot smaller than Earth. It has a canyon that's larger than the Grand Canyon. It has a mountain that's 16 miles high. It has a lot of fascinating things, and as I had said, there's this huge movement that was always towards climbing the 7 summits and getting to the North and South Pole. I can't complain too much. I made a nice living doing it. But I also realized that in the process, what's happening is more and more of this generation is looking at convoluted things to do in order to challenge themselves. You can't be the first person to do a free-fall skydive over the North Pole anymore. We did that in 1980. And then found out we weren't even the first ones to jump over the North Pole. A bunch of Russians did a static line jump literally on the day I was born, March 31st, 1949, over the North Pole. Didn't learn about it until the internet came out. But what's happening is a lot of the kids are saying, well, I can't do that, but I could be the first one to skydive over the North Pole wearing one green sock and one blue sock. So we're getting into this point where there's a lot of convoluted attempts to reach the next stage of exploration or adventure, and we are not supplying them proper outlet to that. And neither is the gear industry and basically the clothing industry, the North Cells, the Nikes, the Adidas. Now, I have been on this kick since I left my old company and sold out for 4 years now. And what has happened is we finally have sort of done enough background that they've gotten involved in it. Next slide. So welcome to Nike's first attempt at a moon boot. Literally, they put the picture out with Nike. This boot, they call it the vegan boot. I love it because there's because basically it's using the ultra high molecular weight polyethylene Dyneema, the stuff that we worked with and transit from the American Cup sailing community to the expedition community, and there it is. So that's our first key indicator that at some point in time, everybody else is going to follow suit, and there's going to be some attention to the new generation and the exploration of the Moon and Mars from the industry that really needs to get involved. If they spent 1% of what they do to hire guys like Michael Jordan, we're there. Next slide. So this one, if you want to look up, I'm going to go through these pretty quick now, but if you want to look up on YouTube and you just do a search and say Mars, Cave, and Man, you'll see from last year a 31-minute slideshow that we did in conjunction with the planetary talk I did at the International Mars Society's yearly convention in Pasadena. And it's pretty informative. It'll give you a good idea. It's narrated by Martin, and it sounds cool because he's, you know, of his Swiss accent, Swiss Deutsch accent. But it'll give you a good idea. You can get back in and look at this stuff. And this is now the part where I'm going to say, okay, how are we justifying going underground? There's a number of reasons to go underground. Besides what we talked about a little earlier, where when you go underground, you don't have to carry your building structures off of the Earth at $250,000 a kilo to get the stuff into space, or whatever the price is now. It's going down, it's still very expensive. But you have protection from radiation. Because basically over the top of you is the top of the cave system that protects you from radiation both on the Moon and on Mars. You also have a stabilized temperature. Yes, you're going to have to bring that temperature up, but if that temperature is fluctuating dramatically between day and night, you're chasing your own tail to a certain degree, where if the temperature is stabilized inside of the subterranean environment, it's much easier to adjust for that. Another thing is dust storms. Dust storms on Mars are going to be a horrendous problem. If you're underground, you can basically mitigate that to a certain degree. It won't go away, but it'll be much less of an issue. It's also interesting that originally we never talked much about the dust issue on the Moon. Well, there's a lot of dust on the Moon, but it sits there. But think of it this way. If you're mining on the Moon, what's it going to cause? It's going to cause lots and lots of dust. And dust gets into all of your equipment and all your clothing and everything else. So if you've established your base underground, or through a series of chambers you can basically decontaminate from the dust, you're in a much better situation than you would be if you put that base facility right on the surface, where it's basically right in the middle of where these dust is going to be while you're digging around on the Moon. Next slide. Also, on Earth, it's not a real big deal for meteor strikes because we have an atmosphere that basically burns most of it up. The Moon has none, and Mars has very little. The Martian atmosphere is 1% of that of Earth. So a lot of micrometeorites and things get down to the planets, get down to the Moon, and get down to Mars. Next slide. Every once in a while, one does get down through our atmosphere. So this is what happened in 1954 in Alabama. It's not too bad, kind of wrecked the roof as an insurance claim. Now think of that in a surface dome on the Moon. And think about the number of micrometeorites and meteorites that hit the Moon relative to those that get through the atmosphere of the Earth. The issue here is severity versus probability. The probability of getting through our atmosphere is very low. The severity, if it does, is very high. The probability of getting through the Moon's atmosphere, which is non-existent, is really high, and the severity is even higher than this. So it's another reason to go underground. There's actually been some research on this. We have some folks at Purdue that are now looking at and working on the math in relationship to how far down you have to be underground in order to mitigate the majority of the potential meteorite strikes. So this is kind of what we were talking about earlier on the slide, where the academic community and the governmental communities are working on things, and what we're doing is we're basically taking that into the company community, into the profit-making community, and turning this kind of information into what we need to know to actually create this environments. Another one that's being worked on right now, and this one is really fascinating because this is a response to how do you get a nuclear, basically energy supply onto the moon that weighs little, has very little impact if for some reason it happens to go on a rocket that explodes. The operating temperatures, this is a 150 kilowatt nuclear generating facility that's the size of a man and weighs about 700 kilos. So this is what they're looking at potentially for using inside of lava tubes. And one of the nice things is we're in conversation with them because the place they want to test them would be somewhere nice underground on the Earth. And so our project fits into this very nicely. So how common are lava tubes on the Moon and on Mars? This is one of the first key indicators. This was basically a Japanese orbiting satellite around the Moon that found one of the first skylights. This is basically a cave in a lava tube. When we first started working on our projects, there's very little indication if it was going to be a viable alternative because of was there water, was there not water? Were there many lava tubes? How do you locate the lava tubes? Now, if you can see through this presentation, all of those questions are starting to get answered. And as they get answered, it becomes more and more probable that this is a reasonable approach. All approaches will probably take parts of different things. So probably be some points of above ground facilities and some below ground. Nothing's going to be like either or. You know, it's not binary. But what's happening is there are more and more indications that going underground is a very optimal approach. In fact, in a presentation, a panel presentation at the end of the presentation in DC with the leading scientists from NASA, ESA, the private communities and everything, at the end of it, I simply asked one question. I said, within this group, how many people here think that going underground for our permanent bases eventually to transition into those bases on the Moon and eventually on Mars is less probable than it was 4 or 5 years ago? There was not a single hand that was raised. So with that becomes more acceptance, and with that more acceptance becomes more resources for the type of thing we're doing. And because we basically started this, at this point in time, we don't really have any competition in the private sector. We will eventually. It's just the nature of the beast. Anybody wanted to know if there was any water on Mars? Okay. Why is NASA partly interested in what we're doing? Because NASA's big push and JPL's big push is still to determine if there's life on Mars. They've also pretty much come to the conclusion that they're going to search for and explore for life on Mars underground. Where's the best place to put your facility if your end objective is to look for life underground? If you can put it underground, that's a lot less foot traffic to get to the site you're going to explore. So this is a book I highly recommend, and it's actually one when people come to me and they say, we're interested in participating in your project, or we're interested in getting involved financially in the project. The first thing I say is get Dutch's book and read it, because then the questions you're going to ask me are realistic questions with a background knowledge of what's involved in what we're attempting to do. I will say that at this point in time, the concept that we're using is very much like we did when we established a company in Antarctica, and that is, if you're interested in participating with us, either on the science end or as an intern or on the financial end, we want participatory people. We want people that will come in and, like we did in the Antarctic, and if, for example, if you're a Steve Fawcett or you're a Dick Smith and you're close to billionaires or you are billionaires, you're out there rolling fuel drums with Fred and Hillary and Neil Armstrong. And the reason for that is it creates a degree of enthusiasm, and it creates a degree of understanding, and it creates a degree of camaraderie within the project, because, quite simply, this isn't a single generation effort. This is an effort that their kids or their grandkids are going to become potentially the captains of industry, the miners on the asteroids, or the next generation of people who would be, the Rockefellers, whatever. It's not happening on this planet. It's happening out there. And it's basically those people who are coming in and opening those opportunities for future generations within their families. So the future. One of the projects I'm starting now is I'm reaching out, I'm getting out of the field. It's, the folks are saying, you know, we made Mike the CEO because he's too old to climb around in the caves anymore. And I said, yeah, go follow me through the caves and see how long that lasts, you know. But anyway, one of the things we're looking at is this whole concept of using blockchain and distributed ledger technology to create an environment where we can reach out into all of the countries of the world in order to bring in the resource people. Right now, unless you're an American or you're from Europe or one of the locations that is involved in the space program in India or China, if you're from Bangladesh, if you're basically from Guyana, if you're from a village somewhere in Tanzania, but you went to Cambridge and got your master's degree and you're back teaching in a village, the opportunity of you right now to get involved in the new space community is pretty much zero. We're hoping that the disruptive technology of blockchain, not basically cryptocurrencies, but the ability to use it to generate something like a golf membership, where those people and future generations get involved, and we can bring those people in and train them. Because the folks that are going to make the facilities on the moon and the facilities on Mars work, those folks aren't the scientists. They're not the astronauts. They're the plumbers. They're the cooks. They're the welders. And you need those as much as you need the rest of the people. Those are the people that make the South Pole Station work. And to date, this species, ours, has not established a fully functional, independent environment anywhere. So that paradigm has to shift. And that paradigm doesn't shift with just the engineers and scientists. It shifts with humanity as a whole, and it shifts with humanity from around the world as a total effort. Okay, the last slide, and I had to put this one in because we're only a month away from the 50th anniversary, but this is Neil Armstrong, myself, and Sir Edmund Hillary standing at the geographic pole in May of 1985. And people often ask me, why am I so enthusiastic about this? I get up here and I just wave my hands and they knock over microphones and everything else that I do. I credit it to these two gentlemen. I was already pretty much exploring, and I'd already pretty much been in every country in the world, and I'd already pretty much climbed the 7 summits and stuff. But somewhere in the back, something was missing. Thank you, Ed. Thank you, Neil. Because of them, I'm standing here today. Thank you.
That was fantastic. Thank you. That was really fascinating. So, okay, folks, have some questions for you?
If I put everybody to sleep,
So, I'm going to actually get one to start off here. In addition, so actually, we talked a little bit this before, and for folks who've been to some of our events before, one of the broad concepts that we talk about is this concept of space scalable industries. And these are where technologies that are ultimately targeted for technology services, whatever, that are targeted for space can be deployed down here as part of that incubation and development. And so I think it's especially interesting for this group here, and the New Space Chicago team. If you can kind of just elaborate a little bit on how what you're doing and your partners are doing, and how that fits into potential terrestrial applications.
Yeah, actually, in many ways, what we're doing has more application to Earth-based type of environments than the space industry as a whole. In low Earth orbit is basically telecommunications, and very little of it has to do with a lot of the other types of things that we do. For example, we've been approached relative to some of the DARPA programs and others for the robotics that will be involved in searching for and placing in the cave systems. The inflatable habitats can be applied just as easily to entering catastrophic environments in urban areas like earthquakes. Mexico City falls down and people are trapped down there. Right now, things like Periscope aren't applied. Things like robots that can get down in there and look for people aren't applied. So when these things get built, they're scalable back to those kinds of applications. growing produce in enclosed environments has huge applications in areas where are devastated by climate change. If you have a population in an area that has lost the ability to grow their own food sources, they're going to migrate. They're going to migrate into another area. That area is already occupied by somebody else. The types of civil disturbances that can create is way more expensive than taking some of the concepts that we have and moving inflatable habitats, and they don't even have to be underground, but basically self-sustaining habitats that allow you to grow produce in areas if those areas are eventually going to pass through a disaster environment. If they're not, you're still going to have issues that are challenging. The medical field, some of the stuff that Scott was working on, Scott Perezinski, these areas all apply back down to what can be basically used on Earth for various things. And to be honest with you, there's probably a dozen of them that I'm not even aware of now. Because some of the things that we're working on are like the miniature nuclear units it puts out 150 kW, are so new that it's going to take a while for us to get involved in those. But certainly we would capture those, because we will have to. Because anybody right now, we are a self-funded effort. We are 4 years into an effort where basically we have been able to fund the thing ourselves by using the Antarctic model. But to progress to the next level so that we can stay ahead of the competition. And the reason I'm not running around in the field in Iceland with a big smile on my face, but I'm coming to things like this, is my next goal is not to just find people who are interested in investing in us, but find people who are interested in coming in with us and saying, okay, what's the best business model we can build in relationship to this? I can build a business model, but 10 people building a business model are going to build a much better one than I can do by myself, okay? And that's what we're looking for. We're looking to bring in the people. We brought in the scientists, we brought in the engineers, we brought in the field people. There are few people left on this planet at the level of expertise that we have pulled into one place. Now we have to protect and keep them. We have to keep them from going to United Launch Alliance or to Spacex, and we have to capture this part of it. And to do that, we basically need to have the same degree of creativity within the financial community that we've had within the field community, the science community, and what have you. So those things are really there. They're low-hanging fruit. 5 years ago, people would shake their head and look at us and go like, that's pie in the sky. Now they're looking at it and going like, whoa, they're going back to the moon and nobody's built the motel yet.
Thank you. It's very relevant for the investment we're looking to build here in Chicago, and unique as well because it's so tied into your philosophy for kind of paying forward and developing this not just physical infrastructure, but philosophical infrastructure as well in terms of people building this out. Other questions from the group?
Okay, I've kind of a two-point related question. Do you get the geology that you need? Because a lava tube has to be at a certain depth to be able to pressurize it. Otherwise, you just blow the ground off. So do you get the geology at the depth that you need on the Moon and Mars?
The answer is probably. Let me give you why. First of all, most people operate under the assumption that when you have a lava flow and you create a lava tube, it's approximately 30 meters from the surface of the flow. But and you step back and think about it, for example, in places on Mars that look a lot like Lava Beds National Monument, we have places, for example, lava tube tunnels. One place, for example, I can give you called stair step. Well, why is it stair step? You can go down through about 6 or 7 different lava tubes. Well, why can you do that? Well, because 1.5 million years ago, the first flow came out. 500,000 years ago, the second flow came out. Both had lava tubes in them. They caved into each other. 300,000 years ago, the next one came out. So what you have is you have these series of lava tubes that are stacked on top of each other, with the skylights from one now becoming the entrances for egress to the one below. And it appears that that is true for sure on Mars. And the way we know this is through kind of indirect observation. There's a gentleman at the University of Tokyo by the name of Professor Honda. I love it. It's easy to remember because it's Professor Honda at Tokyo University. But what he did is he took imaging of the alluvial fans, the outflows, from what we think are the horizontal entrances to some of the larger lava tubes on Mars, and then calculated out the amount of material that was out there, and then figured out where it came through, and then extrapolated from that that there wasn't enough point from the point at the top of the cinder cone down to allow for that much outflow. So there's probably more underneath that came from deeper set lava tubes. Does that answer your question?
When you talk about partially pressurizing the lava tube, how much pressure are you talking?
Okay, there's two things we're looking at. The first one is the minimum amount of pressure to survive in the event of a failure of a primary system. The second one, which is being now just addressed with a group, we have a very active group in Europe. Krista Marie, who's our director in Europe, also works with our architects. Our architect team is in Europe, it's not in the United States. And we also have a group out of the UK that we are now looking at trying to figure out how much pressure we would need in a lava tube in order to grow which types of vegetables and produce, and how much calorific value we lose by decreasing that. So as we move along, we'll start at things that we know work. We'll start with the same pressures that you would have in Cusco or in Lhasa, in locations like that. And then basically lower it, and then basically analyze the growth rates on the plants. So that's kind of a long-term progression. But what we're hoping for is we're hoping that we can get less than 50% of atmospheric pressure here on Earth at sea level. And if we do that, we think we're okay. But again, that's something we'll research. Another interesting project. Right now, there are no really, really big vacuum chambers on Earth to where you can put astronauts in that are going to be on the moon or on Mars, especially, and have them work and function. But one of the approaches we're looking at, and we're looking at doing an RFP on this, is that eventually, if we can pressurize a lava tube, what else can we do with a lava tube? We can pull the pressure out. We can basically, potentially, recreate the atmospheric pressures on Mars inside of a lava tube system on Earth, or another case system for that matter. It really, in that particular case, it doesn't matter. We can go into a coal mine and do this, quite low. The safety factors with that. My undergraduate is fire protection safety engineering. When people start saying we're going to take a really huge volume and unpressurize it, put people in there to live, I start thinking, very carefully about how we're going to approach that, because it's a risky environment. But those potential opportunities are there. And the other half of your question was, or that? Okay.
Amazing talk, thanks a lot. So I'm very into food and entertainment, so these questions are regarding those two. So you mentioned like a few potential candidates for the veggie, right? Grow under lava tube. Why not algae? I know like green veggie play like a huge psychological factor for a human being, but why not like algae? Like what will be your top like 3 candidates in terms of like plants that you recommend to grow under the lava tube? Like,
yeah, that's a
why?
Okay, so that's a pretty good question. I'm not sure I have a conclusive answer for that. I'll tell you what.
Not banana. I know not banana. We can get that one else. Well, what else? What else? Like, my interest is I know the industry is trying to catch up. Like, how can we solve the food supply, right? Like issue, like by harvesting a lot of the algae. So I'm like, what is that actually part of the potential solution, or if not, why not? So as a first step, like to.
I can tell you what we're looking at now in relationship. So and this is actually kind of a funny story, but one of the things we're looking at for food produce is on Earth, for example, cutting out all of the middlemen. Okay, so baleen whales go to the Antarctic and they scoop up a whole bunch of krill, correct? Yeah. Okay, so if they do that, then the krill feed the penguins, which then feed the leopard seals, which then feed the killer whales, which theoretically goes up to us. One of the things that we're looking at, is kind of a funny story, is water bears, okay? Because it takes about, I think it was established, it takes about 700 to equal the same calorific value of one krill, okay? So if you can grow, if water bears already survive, everybody know what they are, basically. Okay, so if they can already survive in really, really light atmospheric environments, and they're digestible, then they're a really nice source of protein, combined with algae and other things of that nature. So, are they digestible? This was a question that was posed at the 18th annual Vulcan Speleological Society meeting at Lava Tubes National Park last year. And a couple of people kicked in to start looking at it. And yes, number one, yes, they are digestible. Number two, that's as far as we've gotten on that. The algae, there's a couple of interesting things in the growth of algae, in that there are 2 research projects right now that are actually looking at using algae, or have presented us the idea of using the algae within the internal and external shell systems of the inflatable habitats. So the folks in England that are working on that are just now starting. They've actually gotten some funding to work on that. The rest of the question, it's really outside of my area of expertise. So.
But that's great, thanks. So the second part is about entertainment. You mentioned you guys are doing or started the project about Olympus Mons, like 3D VR climbing thing. Is that where?
Let me go over here. You just
sorry.
We'll do this. I apologize. Some years ago, I had an aircraft crash and burn that I lost an eardrum on one side. So.
No, I can speak louder. So where are you guys on the project for this 3D climbing thing?
Oh, yes. Okay, where are we on the project for the 3D virtual reality climb on Olympus Mons? We've gotten a lot of publicity on it, and basically we've had some funding interest on it. And the group that is actually committed to doing the virtual reality project is, they committed to 3. The first one they did was basically for the Mars Society. They were doing one which is virtual reality inside of the Mars Desert Research Institute. They've pretty much finished that, right? Okay, the second one is a program for us in Iceland that's going to be virtual reality through the cave systems, where people can go and explore the cave systems. And that one is going to start, if all goes well, this summer. From that, we're hoping to take those and present them to a number of companies that I have the ability to reach out to the CEOs. The Vanity Fair Group, North Face, okay? They sponsored a lot of my expeditions in the old days. The old folks aren't there, but they pick up the phone and say, talk to Mike. So what we're looking at is the funding for that. The technology's in place, the ability to do all of the rest of it's in place, and now that Nike has put out this thing where they've pretty much stated that we know that the moon isn't part of Mars and we need boots on Mars, we're kind of ready to go with that. Last year, it looked a lot more promising, then it sort of fell away, and now it's starting to pick back up. And so I'm expecting that, if all goes well, there'll be a virtual reality project that hopefully will be in science museums like the Lawrence Hall of Science at Berkeley, places like that, where the kids can go in and do the virtual reality climb on Olympus Mons. But again, it's a funding issue. And in a way, this brings up an interesting point. We're pretty limited in our resources, and we focus it predominantly on field projects. So when people come up like NASA and they say, you know, you need to put in an RFP to do this because we'll give you the money, and here's the 9,643 pages you need to fill out to do it. I have a choice. I can either go ahead and work with the materials that we have to continue building the habitats, or I can pull somebody away from that and work on filling out the forms. And at this point in time, we felt that doing the field stuff was more important. I used to have a joke I told Scott Perezinski about NASA. It was always, you know, the old standard joke. How many astronauts does it take to screw in a light bulb? You know, I go, how many astronauts does it take? It only takes one. But it takes 7,600 pages of documentation and a 64-person, 24-hour support team. Okay, and that's our problem, and that's one of the things I want to get a financial group together and say, where do we need to be able to access things like hiring somebody who can write proposals for us and other things of that nature, so that field people can do what they do. I do what I do, which I love doing this. I love talking to people and listening to this stuff, so I don't have any problem doing this, but we need the other part of it too. And right now, that basically means bringing resources into the company instead of me throwing the money in from the sale of my old company.
I'm sorry I came in late, earthly babysitting duties. But I'm wondering, which of the activities you're involved in, if any, have utilized information developed from Biosphere 2?
Okay, so my wife is smiling. I will start the answer to that to say, before 4 years ago when we moved to Chicago area for her career, as opposed to mine, I, again, somewhat retired, we lived in a little town, first called Eloy, Arizona, and later Casa Grande. And we used to have our pancakes in Oracle, Arizona. And if any of you know where Biosphere 2 is, Biosphere 2 is in Oracle, Arizona. So, to answer your question indirectly, I have one of the three architects that we currently are developing sort of the interiors, the living spaces and what have you, that was involved with Biosphere 2 and did her master's research on some of the stuff that was Biosphere 2. Me personally, I'm a very strong advocate of, if you hire intelligent people, you don't tell them what to do, they tell you what they need to do. And so the Biosphere 2 is part of a series of programs that they're looking at. And they want to carry forward into creating, and this is actually very new. This is where some people approached us, literally 3 weeks ago, to say we want to carry that model through and create a place where we can do the same thing in a lava tube. And we have some locations that we're looking at in Australia, North Africa, where the funding for doing that is potentially there. United Arab Emirates, for example, is very aggressive looking at funding in relationship to what we're trying to do.
There were two particular things about Biosphere 2 that impressed me. The first one was the revelation of how much oxygen they lose through the ground, which I assume probably figures into all the things you're doing. And the second was how absolutely labor-intensive was sustaining themselves from farming. And I understand they barely could keep themselves alive, and how much effort from sunrise to sunset it took just to do that. What problems do you see have already been resolved that may ease that particular burden?
Okay, one of the things that we are looking at right now is the concept that a subterranean greenhouse environment on the moon will arrive and be robotically tended before the astronauts get there. It serves two purposes. The first one is to see if you can physically do that. The second one is then you don't actually need to establish as your first set of bases something underground, but you have something that you can use as a research and development effort. So the intensity of the farming in relationship to the subterranean locations, we're hoping will be offset through artificial intelligence and redundant robotic gardening. It just makes sense, okay? It also gives us a lot of information for it to get there. And you know, what I alluded to earlier, this is not binary. This is not, let's go underground or let's stay above ground. This is landing your lander and then probably being mobile with a mobile base camp, and then probably setting up something on the surface and then transiting to underground. It's my personal opinion that the transition to underground is going to be a population and an objective-based thing. As I had mentioned earlier, we have never put a self-sustained environment. We have not done one at the South Pole. We have not done one under the sea. And yet what we're saying is we're going to establish a self-supporting base or facility on Mars. And the place you're probably going to see if that's successful or not. There'll be some things. There'll be some things on Earth we'll do. There'll probably be some things that Aquarius will probably be expanded, and they'll probably be looking at this. Literally, when I was working in the Antarctic, it was literally 13 seasons. There were times where I never saw the sun go down because I would work in the Arctic for 3.5 months and then go to the Antarctic. There were times where I would work all 7 continents and the North and South Pole in the same calendar year for 8 years running. I got home like 18 months. But in those days, yeah, exactly. That's what she says. But although we met in Antarctica, so I got it. But anyway, the point of it is that when I was down there, you literally couldn't have a garden in Antarctica. You couldn't bring in anything that was a plant from one of the other continents and get it down there because it might contaminate the environment. There was on King George Island, Islas Rehory, there was a Polish base called Artowski, who had a wonderful garden with tomatoes and all kinds of stuff in it. It was literally a greenhouse off the side of the place, right next to Bellinghausen Russian station, that they made them take it out. Okay, so one of three things that were required to be removed from Antarctica during the old treaty. Number one was Artowski's garden, because they were the only ones really growing anything down there that everybody knew about. The second one was dogs, because the Japanese dogs survived over winter, and that created a third. Anybody know what the third one is? The third one was the United States nuclear power plant that came off the old Savannah merchant ship that powered McMurdo Station. McMurdo and the United States National Science Foundation put that in without asking for any permission from any one of the other Antarctic Treaty countries, and it got removed very quickly. They were also a little annoyed at that point in time because we have an aircraft called an LC-130. People familiar with it? It's a Hercules aircraft. It's on skis. They use JADOs to get in and out. To tell you how the political relationships of America with the rest of the world are in relative to territorial overlapping claims in the Antarctic Treaty, I may be wrong with this to this date, but as far as I know, and as long as I followed it, the United States was willing to sell any type of fighter aircraft to any of their basic allies, F-18s or F-22s to the British and Canadians. We never sold one single ski-equipped Hercules aircraft to any other country in the world, period, because it allowed you access to the interior of the Antarctic. And if you have your bases on the perimeter, and you start putting bases in the interior, then your claim for your pie-shaped piece of the Antarctic continent becomes much more viable. So the Canadians don't have a rescue LC-130. Brits don't have a rescue LC-130. Now, somebody may research this and tell me that that was up to 5 years ago or 10 years ago. But I'm simply, saying that that's an interesting thing that happened, and in many ways it may well correlate to claims that eventually evolve on the moon, especially in relationship to mining. I ran off on a bit of a tangent, but hopefully you're okay with that.
Hi, I'm a recent graduate of Purdue, and actually had some conversations with the professors that started resilient extraterrestrial habitats at Purdue when it was being started. I'm just curious what work you're doing with them now, because you mentioned it during your presentation.
Okay, with who?
Resilient extraterrestrial habitats at Purdue.
The ref, your slide
Yeah,
that says
okay.
ref.
Yeah.
So they're doing pretty much all science, okay, but it's multidisciplinary. So our relationship with them is fairly new, and the objective of the relationship is for them to be able to field test things and concepts that they come up with within subsets. Our goal is really simple, and that's to be able to eventually establish, through an analog system in all the subsets, a turnkey facility that can leave this planet and go to the moon. Their objective is the science research and validation of various subsets that would be integrated into that, and that's where our basic relationship sits at this time. We also have the same type of relationship with the University of Colorado School of Mines, with Michigan Technology Institute, and a number of other folks. So we have this small unofficial group, and it's called the Allied Space Group. And what it is, it's a set of academic institutions, a little bit of government, mostly the folks through the agricultural departments and stuff in Iceland, and us on the commercial side, all looking at how can we benefit and help each other reach this overall goal of establishing the development and testing here on Earth of a potential turnkey facility to initially put on the moon. And this gets back to why robots tending gardens. Well, you're not going to tend gardens with robots unless you figure out how to do it here first. And that's probably going to happen in Iceland. And what's in the garden, okay?
So one thing that occurs to me is if you're looking for money, have you thought about approaching very wealthy people to build shelters for the collapse of civilization, for example?
I have, but unfortunately all the ones I know are dead. No, seriously, I mean, all of the people who sponsored a lot of the stuff I did in the past, for example, everyone here more or less familiar with Steve Fawcett?
Yeah.
Okay, well, Steve and I were good friends. We grew up in sort of close to the same neighborhoods in Southern California, and I got him into the whole adventure thing through a bunch of stuff we did. We went down and stayed in underwater habitats, and we went up. He went with me on the North Pole Expedition with Seb and Hillary and Armstrong. And yes, people criticized me because I invited him for free. He didn't pay anything, and Steve doesn't give you money unless you ask for it at that point in time. But he and a number of other people like him, I had close relationships in the 80s and 90s. The new generation, the folks coming out of Silicon Valley, are probably going to be communicating more with people I work with inside our company. And at some point in time, I may have to sit down and talk to them, and eventually they will probably throw me out the door. We don't know. Yes, using people who are billionaires who are not currently within the race to space group, the Musks and what have you. Let me give you a really interesting example of why.
Battery.
Battery died?
Did I?
Probably the battery out.
Probably battery.
I can swap it out, but maybe you can take that much.
That's okay. Yeah, that's fine. All right. Okay.
Remember, we used to-
So here's the double-edged sword with the industry, private company issues associated with what we're doing. And I'm going to give you a little story, a real quick one. I was involved with and developed the racing cells for the America's Cup before they went to the Rigid Wings. All of those cells were built in a place called Minden, Nevada, by North Cells. I was project manager there. I built their factory as project manager for building their factory in Sri Lanka. During the America's Cup, we had a saying that if a plane from the Minden airport crashed into the building, the America's Cup would have to be canceled because it was the only facility in the world where those cells were built. So on a mold over here, three-dimensional shaping mold with the guys in the hang glider bags going back and forth, and you can guess where the hang glider bags came from with my background. But anyway, they would make these cells, these composite cells. And over on this mold would be Alinghi, the guys from Europe. And over on this mold would be United Arab Emirates or Emirates, New Zealand. And over here is Oracle BMW. Now, all of these cells were being built on all of these molds. And we had NDAs in place. So there's certainly no way in the world we could tell Oracle BMW what Alinghi was doing or what Alinghi was doing that New Zealand was doing. But I could sit there and I could look at them and say, that Alinghi cell has the best roach I've ever seen, and the concepts of how they tack down the clue is #1. But over here, you know, on one of the other teams, it sucks. But boy, look how they did this. Look how they did the roach on that. And look how they did the battens on that. That's cool. That's really great. So I could step back and I could take these 3 cells and I could build you a cell that would have outperformed any one of the 3, because I would have taken the good things from the 3 different cells. But I certainly couldn't tell any of them what the other one was doing. Now, so for billionaires doing races to win the America's Cup, there's no way I'm going to do anything with that, because the worst thing in the world I could imagine happening to me was getting sued by 3 billionaires. Same thing is happening with us to a certain degree with NDAs within the private industry right now. There are at least 2 projects that are under NDA right now that I know of that are duplicating, and probably 3 that are duplicating exactly the same work and are having exactly the same consequences. And I have no way, and I said this in Washington, D.C., I have no way of figuring out how to turn that into a more efficient kind of operation. When it was government, they were incredibly effective. They could get men to the moon. They were horribly inefficient. Industry is pretty effective, but their efficiency isn't all that much better, because there's a lot of redundancy that really doesn't need to take place if you can figure out a way to protect everybody's IP and their patents, yet still combine them into one project to reach your goal. Because this goal is for humanity overall. It really is. It's for us as a species.
They're allergic to joint ventures? The companies are allergic to joint ventures?
The companies are allergic to joint ventures if their venture capitalists perceive a loss of revenues in association to what that would entail. It's more now, rather than a joint venture, it's more absorb the technology, bring it into your thing. There are not many people who know what Elon Musk is doing relative to habitats right now. It's pretty quiet. We only know parts because there's little things we play with that we're asked to consult or play with. The same holds true for the others. So that question, the way I would respond it would be the same as asking the 3 teams that are doing the America's Cup, what's your chance of you guys doing a joint venture? Didn't fly very well.
Not enough glory.
After the race. Okay, well, I don't want to drag this on, but I'd like to thank everybody for coming and wonderful questions. And I apologize for trying to, like I said here, I came down from very high to very low very quickly one time, and all of me except one eardrum got through it okay. Okay, thank you very much.
Thank you again, Michael. That was fantastic. One more round of applause for Michael, please. Everybody's welcome to stay. We got some drinks and refreshments back, and please enjoy, stay, network, and stay tuned to the website and the newsletter for the next event. Thanks, guys.